So when we are trying to study the correlation, right, that's like a two-dimensional study, right? So you will see the homework questions here, they are relatively simpler than the other ones we have so far, right? Question number 1. A positive relationship exists when both variables increase or decrease at the same time, right? That's what we mentioned in class, right? If the variable A going up, variable B also going up, so they are going the same direction, or you say both increase or both decrease, then they have the positive relationship. Number 2, determine the type of relationship shown in this picture here, right? So you can see X value going up, Y is also going up. It is a positive one, right? It's pretty close on the line, or like kind of a curving a little bit, but it's going up, right? Now, positive. Range of correlation coefficient is from 0 to 1. Everybody, that's false. Remember, correlation coefficient ranges from -1 to 1. Number 4, 10 pairs of points, right, yield a correlation coefficient R is equal to 0.79, alpha equal to 5%. Which of the following statement is right? So in this case, we have to use that T formula, a very special T formula from this chapter here, everybody. So going back to the next notes for that correlation, we have a specific example using that T formula. The degree of freedom, be careful, is n-2. That's the one I want to remind you for that. So go back to that lecture notes to do the calculation. You will determine if this is true or false. So I'm going to skip that. Number 5, a regression line can be used to show the trends in data. That's right, right? That's the one we want to see, the trend. A regression line was calculated as y equal to a plus bx. B is -3.2. So in this case, we say the slope of a line is -3.2. That's right. That's the slope, right? What negative, right? What we call this number 9.7. That's the intercept. Now, if we know the regression line is given, now we have a new value of x. So we plug x equal to 2 into this equation. So 2 multiplied by 9, we got 18, right? Minus 5 got 13. You see, that's an elementary school question, right? One more year, my daughter in 3rd grade, I think she can answer that. Now, if the correlation coefficient is 0.93, what's the unexplained variation? Everybody? This is the tricky part we mentioned in class, right? So that's the R. R is equal to 93%. We have this correlation coefficient, right? The concept, coefficient of determination, R square, right? So 0.93 square, that's to, I think is if you multiply 0.93, multiply 0.93, you will get this number here, but that's not our answer. The answer should be 1 minus that. Why? Because that's the one we say explained, right? So number of data points explained by that line. Or you can say like the data points that kind of aligned on this line, right? But they are saying unexplained, everybody, is what? It's 1 minus that number, right? So which is 13.5, that's the answer. Easy peasy. Now, number 9, as a researcher connects more and more data, 25% prediction intervals in general. That's a tricky question, everybody. So that's the one we mentioned previously. This is a what? Prediction interval, 95% prediction interval. In other words, it's what? It's a confidence interval. So in a confidence interval, remember, we have, remember we have that case, is that right? So it's like usually is the X bar, right? Minus something. In one of the formula we are studying is like Z alpha divided by 2, right? And then multiply this sigma over square root of n. That's the lower limit, right? When we simplify the case here. So remember, 95% corresponding Z alpha equal to 2 is what? It's about 1.96, everybody? 1.96. So 1.96 is what? Is very, very close to 2. Is that right? It's very, very close to 2, everybody. So that's the reason they just like 4 times or 2 times coming from, okay? So that this question here is a little bit tricky, okay? Now, if I try to draw this one here, say here is my sample average, right? X bar here. Right? So they're asking, let me see, they're asking, as the researcher gets more and more data, everybody, in other words, the sample size is getting bigger and bigger. You can understand that way, is that right? Sample size is getting bigger, divided by this number is going to be smaller, is that right? Because the denominator is bigger. So in other words, this whole number here is what? It's a smaller. It's smaller, is that right, everybody? Follow me? So you divide by a bigger number, makes the whole number smaller. Everybody? Right? So smaller, and now we know this is the center, right? And then you minus something. Now we know that something, when the sample size n is getting bigger, that something is going to be smaller, means what? It's going to be lateral. So that is lateral. Okay, so all 4 of them, they are lateral. Okay, we cannot cross out anything yet, right? Okay. Now, I mean, at least you understand what I mean, why it is lateral here, right? Now, but the Y's is always, we are trying to see, is that 4 times or is it 2 times, everybody? The Y's, right? So here we are trying to see each side here, you minus twice, right? You minus 2 of that, like Y is 2 is like 1.96, is that right? So on the left side, you minus 2 of them. On the right side, you plus 2 of them. So overall is what? It's 4 times. So the answer is either A or B, right? It's not C and D, everybody. Question here is the, let me see, the Y's are more always the slope. That is not right. This part here, we mentioned that the standard error of the estimate, as this part here. The answer is A. Now, number 10. If the correlation coefficient R is equal to 0.566, find the coefficient of determination. What's that? That's R squared. Easy peasy. In Goodlist fit test, between one observed frequency and one expected frequency, the degree of freedom are equal to the number of categories minus 2. Everybody? That's not right. Minus 1, right? We have the example, we have like 5 different flavors, right? Degree of freedom, 4. In the chi-square goodness of fit, when there's a close agreement between the observed value and expected value, the chi-square test value will be small. All right, this is a tricky one, everybody. Let's go back to our lecture notes here. This one, right? So they are trying to see, where's that? This one here, question number 12, right? So they are trying to see, this is our chi-square formula. We have the observed minus the expected, right? Now they are saying there's a close agreement. For example, like O1 and E1, they are getting more and more close. Means what? The difference will be close to 0. And 0 square it will be even smaller, is that right? So in a case when the difference, when they are getting closer and close, this value, the whole value will be small, right? So they say the chi-square test value will be small. That's right, everybody, follow me? So that's the meaning, what they are talking about. They are talking about this formula. When observed and the corresponding expected are getting close, means the difference will be close to 0. The square of that is even smaller, right? That's 2. Number 13, let me erase those ones. Right. Okay, so the null hypothesis should not be rejected for the data given in the figure below. Everybody, this picture here, right? We don't have too much information given here. So there's something we have to assume here, right? This graph here means what? Let me see. The one that we highlight is coming from the data, everybody. The one that we highlight is coming from data from a calculation. So we are here. Data tells us 9.236. Critical value, that's the one without highlight, 3.471. So in this case here, data is further away from the center. We are going to reject the null hypothesis. We are going to reject the null hypothesis. So when they say the null hypothesis should not be rejected, that's false. Number 14, that's a question. A biology professor claims that 15% of students will get an A, right? This one get a 25% and get a B and so on, okay? What's the value of chi-square? Everybody, we are using the same formula here, right? The same formula. But I want to remind you here, it's a little bit tricky. Why? Number 1, when we have this grade 1, 2, 3, 4, 5, corresponding to grade A, B, C, D, F. Okay, one thing. Another thing, when we plug the number here, if you plug, this is observed, right? Say O1 equal to 13. What's E1, right? E1 is like, how many percent you got an A? 15%, like 0.15. Everybody, if you do that way, 13 minus 0.15, something's not right. We cannot do that. Why? Because they are not even on the same scale. We have 13 people, but minus 0.15, no good, right? So what's happening here is we have to transform them into the same scale. Here we are talking about percentage, each of them. So to be fair, this one should be percentage also, right? Should be 13 divided by, if I should draw here, 13 divided by, how many, what total? 131. It's like close to 10%, right? Close to 10%, right? So that's the percentage we are using to do the calculation. Okay, so that's a tricky part. I want to mention that here. All right. Number 15, find the area to the right under the chi-square distribution. So that's the using the chi-square table. Everybody, we have mentioned for this table here, right? Chi-square table, this table here, right? The beautiful, another 1 page, right? Previously, T table, 1 page. It's chi-square, another page. So this one here, we have upload onto the Canvas. So you can print out, you have to use that for the coming homework and exam, okay. We are not going to cover the details for that. A contingency table made up 8 rows, 4 columns. What's the degree of freedom? So n minus 1, 8 minus 1, multiply 4 minus 1. Remember the formula we just covered, right? So you have to multiply them. Chi-square independence test can use to test the independence of 2 variables. That's right. So this is a contingency table, men, women, chicken, hot dog, hamburgers, any preference or not, right? That men and women, do they have a significant difference? We have those examples covered earlier. Doctor 1, Doctor 2, food, more the pets. Okay, that's sort of similar, right? Continuous table, right? The tricky part is to do the calculation. Everybody, the last two example here, last two homework here requires a little bit of calculation. Other than that, it's pretty straightforward, right? So that's the reason the final usually is easier.